Now there are two types of diffraction. The first is the Fresnel class of diffraction. So in case of Fresnel class of diffraction, first of all we know that to observe the diffraction pattern we need some source, some aperture or obstacle and some screen on which we can observe the diffraction pattern. So in Fresnel class of diffraction, the distance between the obstacle and or aperture we are using, we can use either obstacle or the aperture, and so the distances between the source of light and the aperture or obstacle, and the distance between the aperture or obstacle and the screen, both are infinite. Okay, so the source of light, or in case of Fresnel class of diffraction, the source of light or the screen or both are at finite distances from the aperture or obstacle. Okay, so either the source of light, it can be at finite distance from the aperture or obstacle, or the screen, or both the source and the screen can be at finite distance from the aperture or obstacle. That is, we can measure that distance. Okay, and in this arrangement, no lenses are used to make the light rays which are coming out of the source, or which are suffer diffraction after passing through the aperture or obstacle. To make the rays parallel or divergent. And so as no lenses are used to make the rays parallel or convergent, okay, so the incident wavefront is not plane but either spherical or cylindrical. Okay, so the spherical wavefront, if we are using a point source, and cylindrical wavefront if we are using a linear source. Here is, as you can see, that this is the general setup for a Fraunhofer to observe the Fresnel class of diffraction pattern. So here we have the either obstacle and aperture. Here is the source and here is the screen. So we will need just the source, the obstacle and the screen. We don't have to use any lens or any other device. Okay, so as you can see, as we are not using any lens, so the incident wavefront is spherical. It can be spherical or cylindrical. So if the point, it is point source, then the it is spherical, and if it is, we are using linear source, then it is cylindrical. Now the second type of diffraction is the Fraunhofer class of diffraction. So in this class of diffraction, the source, both the source of light and the screen, both are effectively at finite distance from the aperture or the obstacle. So why we are using the term effectively? Because generally, if the source of light is at infinite distance from the aperture, then even if suppose if it is sun, then you will get enough amount of light passing through the aperture or around the obstacle. But if the screen is also at infinite distance, then after diffraction, the light has to pass infinite distance to reach the screen. Okay, and then you have to observe the diffraction pattern, which is next to impossible. Okay, so that's why we are not using any source or screen which are actually at infinite distance, but we are making some arrangements such that they are pushed to at infinite distance from the aperture or obstacle. That's why we are using the term effectively. Okay, so how this can be achieved? This can be achieved by using two convex lenses. Okay, one is used to make the light from the source parallel before it incident on the aperture or the obstacle. So first of all, if you look at this diagram, so here we have this aperture. You see that in reality the source and the screen both are at finite distance from the screen. Okay, but we have made some arrangements such that the source and the screen are effectively pushed to infinity. Okay, the arrangement acts as the with respect to the aperture as if the source is situated at infinity and the screen is also situated at infinity. How this is possible? So here you see, as the source is a point source, it is emitting spherical wavefronts. Okay, then a lens is placed at the focus of the source. So as a result, after passing through the lens, the light rays are rendered parallel. So now the wavefront is plane wavefront. Okay, so the wavefront is now plane wavefront, and this plane wavefront is, so we have this plane wavefront incident on the aperture. So if plane wavefront is incident on the aperture, we can say that as if the light ray is coming from a source at infinity. Even though it is as if the plane wavefront is as if the light rays are coming from a source at infinity. So even though the source is placed at a finite distance from the aperture, by using a convex lens we have pushed the source into infinity. Okay, then again after diffraction the light rays are parallel. Okay, so the wavefront is plane wavefront. Then after passing through the lens, they have become converging. Okay, so that's why we have this spherical wavefront. Okay, then a screen is placed at the focal length of this lens. Okay, and then these rays are focused at on the screen. Okay, so all these rays are focused at a point over here. Okay, so at this point where the rays are focusing, the screen is placed. So the screen is placed at focal length of this lens. Okay, so all these diffracted rays after passing through the lens are focused over here where the screen is placed. Okay, and we know the parallel rays after passing through the lens are focused at the focal length where the screen is placed. Okay, so with respect to the screen, we can say that these rays are coming from infinity, as they are parallel rays which is received by the screen, which is this is the diffracted rays. They are coming from infinity. So with respect to the screen, the aperture is also pushed to infinity. Okay, and we can say that with respect to the aperture, the screen is placed at infinity. So in this way, by using two lenses, we have effectively pushed the source and the screen to infinity. Okay, so now so here you can see that the plane wavefront, which is the incident plane wavefront, and this is the diffracted plane wavefront. So now as we have used the lenses, the incident wavefront and the diffracted wavefront are plane wavefront. Unlike the Fresnel class of diffraction, where the incident wavefront and the diffracted wavefront both are either spherical or cylindrical. So there are these two types of diffraction. One is Fresnel class of diffraction, another is Fraunhofer class of diffraction. Now we'll discuss various cases of Fraunhofer class of diffraction.